The ultimate velocity is the speed of light, the universe's zenith, or the awakening of human consciousness. The human mind, a delicate yet immensely complex bioelectrical system housed within the cranium, has perpetually sought the absolute limits of existence, the fundamental constants that govern reality, and the outer bounds of its own potential. Among these quests, few concepts are as tantalizingly persistent as the question of ultimate velocity, the theoretical maximum speed achievable within the known cosmos, a threshold traditionally, and emphatically, designated by the speed of light in a vacuum, often denoted by the symbol c, a constant whose precise value, approximately 299,792,458 meters per second, forms the bedrock of Einstein's special theory of relativity, a framework that reshaped physics at the turn of the 20th century, postulating that nothing possessing rest mass can attain or exceed this speed, because as an object approaches c, its relativistic mass increases infinitely, requiring an infinite amount of kinetic energy to accelerate it further, a physical impossibility within our current observable universe. Yet the very persistence of this inquiry suggests an inherent human dissatisfaction with established physical boundaries, a yearning to transcend the very rules that define our perception of reality, perhaps suggesting that the true ultimate velocity lies not in the propagation of electromagnetic radiation, but in a more esoteric, perhaps internal, phenomenon, the awakening of human consciousness. To fully appreciate the dichotomy presented, one must first ground the discussion firmly in the established physics of light. The speed of light, c, is not merely the speed at which photons travel, it represents the causal boundary of spacetime, the maximum rate at which information, energy, and indeed, cause and effect can propagate. This constancy, experimentally verified over centuries, from the aberration of starlight observed by James Bradley in the 1700s to the Michelson-Morley experiment in the 1800s, which definitively ruled out the existence of a luminiferous ether, forms the second postulate of special relativity. Modern advancements continue to refine our understanding, with recent experiments pushing the limits of speed measurement, confirming c to an astonishing degree of precision, essentially defining the meter in terms of time and c itself. This speed governs everything from planetary mechanics to the expansion rate of the universe, the Hubble constant itself being intrinsically linked to the scale factor defined by the spacetime metric where c reigns supreme. Consider the implications of this cosmic speed limit in astrophysics. When we observe distant galaxies, we are looking backward in time, the light travel time acting as a temporal telescope. The observable universe, therefore, has a boundary, the particle horizon, dictated precisely by how far light could have traveled since the Big Bang, approximately 13.8 billion years ago. If information could travel faster than c, our entire model of causality would collapse, effects could precede their causes, rendering predictive science meaningless. Theoretical constructs attempting to bypass c, such as the hypothetical Alcubierre drive, rely on manipulating the spacetime metric itself, compressing space in front of a vessel and expanding it behind, rather than accelerating the vessel through space relative to a local inertial frame, thus remaining technically consistent with special relativity by never locally exceeding c, though the energy requirements, often involving exotic matter with negative mass energy density, remain astronomical, bordering on the physically unattainable based on current quantum field theory limitations, such as the requirement for Casimir-like energy densities over vast scales. However, the narrative shifts dramatically when we pivot from the quantifiable speed of physical propagation to the qualitative realm of subjective experience and cognitive processing, the awakening of human consciousness. What is consciousness, in this context? It is not merely the electrochemical signaling within the brain, which operates at speeds drastically slower than light. Neuronal action potentials propagate along axons typically at speeds ranging from 1 meter per second to over 100 meters per second, a speed range laughable compared to c, but rather the emergent, integrated whole of subjective awareness, self-reflection, qualia, and instantaneous recognition or insight. This concept ventures into the murky territory bridging neuroscience, philosophy of mind, and even quantum cognition theories, although the latter remains highly speculative and controversial. If we define speed in the context of consciousness not as spatial velocity, but as the velocity of comprehension or the rate of information integration across vast, disparate datasets, then the comparison becomes fascinatingly non-trivial. A human, upon perceiving a complex, novel scenario, say, understanding a profound mathematical theorem or experiencing a sudden, comprehensive epiphany, can seemingly process and internalize that realization instantaneously, or at least far faster than the time it would take for light to traverse the physical distance between the sensory input organ and the highest cortical processing centers, even accounting for the speed of neural transmission and synaptic delay. Let us examine the neuroscience underpinning this perception of immediacy. When an external event occurs, the sensory input, photons striking the retina, pressure waves hitting the cochlea, is converted into electrochemical signals. This signal travels through sensory pathways, processed sequentially in various brain regions, the thalamus, primary sensory cortices, association areas, before yielding a coherent percept. Studies utilizing techniques like functional magnetic resonance imaging and electroencephalography reveal that even simple recognition tasks take measurable time, often hundreds of milliseconds. For instance, recognizing a familiar face in an image can take approximately 300 milliseconds from stimulus onset. Yet, the feeling of understanding, the subjective aha moment, often seems divorced from this measurable latency. This leads to the philosophical concept of the specious present, the small window of time that we subjectively experience as now. Consciousness appears to possess an uncanny ability to bind together disparate sensory inputs and memories into a unified narrative, often smoothing over the inherent delays in neural processing. This binding problem, central to cognitive science, suggests that the integrated conscious experience operates at a temporal resolution that feels instantaneous across a wide domain of input data. Could this apparent speed be a sophisticated illusion generated by the brain's predictive coding mechanisms, where the brain constantly anticipates and updates reality, minimizing the perceived lag? Or does it hint at a processing mechanism that harnesses non-local or quantum correlations, as some highly theoretical models, such as those proposed by Harmeloff and Penrose involving orchestrated objective reduction within neuronal microtubules, speculate? While the quantum consciousness theories lack robust empirical verification and are often criticized for invoking quantum mechanics in warm, wet biological systems where decoherence is expected to occur almost instantly, they represent the frontier of pushing the limits of what biological computation might achieve. The comparison sharpens when we consider the speed of thought versus the speed of light in practical terms. Light traverses the diameter of the Earth in approximately 6 to 7 milliseconds. A human thought, however complex, if executed within the bounds of conventional electrochemistry, is bound by these millisecond delays. Yet, a person can formulate a complex ethical judgment, incorporating years of accumulated learning and experience, in a fraction of a second following a single, novel piece of auditory or visual data. This integration speed, the ability to navigate a vast internal knowledge graph, seems to operate at a functional speed far exceeding the linear propagation limits imposed by physical distance and material constraints. To formalize this, let us consider the information capacity. The speed of light dictates the rate at which energy and momentum can travel across space. The speed of consciousness, if we must assign it a metric, might be related to the rate at which complexity can be organized or meaning can be extracted. If we view information as existing in a high-dimensional state space rather than three-dimensional space, the concept of velocity becomes distorted. The distance traveled in state space, moving from ignorance to understanding, might be traversed almost instantaneously if the architecture supports massive parallel processing capable of collapsing the state space into a single solution, much like a phase transition in physics. Furthermore, consider the phenomenon of intuition or creativity. These cognitive leaps often defy linear, sequential processing. A scientist might struggle for months with an equation, only to find the solution arrives whole, fully formed, during a mundane activity. This sudden restructuring of internal models, this rapid traversal across the landscape of potential solutions, seems to bypass the slow, painstaking step-by-step relay race of conventional neuronal firing. Is this faster than light, in an information-theoretic sense? Perhaps not strictly, as the energy must still be expended in the brain, but the effective velocity of problem-solving surpasses the slow march of sequential calculation that light imposes on physical travel. The most compelling argument against the supremacy of light speed, within the context of human experience, arises when we consider the potential for non-local phenomena in consciousness, however speculative. Modern physics, particularly quantum entanglement, demonstrates correlations between particles separated by vast distances that appear instantaneous, violating classical notions of locality. While the no-communication theorem rigorously prevents entanglement from being used to transmit classical information faster than light, the measurement outcome is inherently random until correlated with a reference frame moving slower than c. It leaves open the profound possibility that consciousness itself might be fundamentally linked to quantum processes that are inherently non-local. If consciousness is indeed an emergent property of underlying quantum phenomena within the brain, then its informational substrate might transcend the limitations of spacetime defined by c. Recent, albeit preliminary, explorations into consciousness and quantum mechanics, often touching upon theories involving macroscopic quantum coherence, suggest that if such coherence is maintained across neuronal structures, the processing might not be restricted by the relatively slow speed of classical electrochemistry. Imagine a system where the entire structure of a concept is accessed simultaneously through entanglement correlations rather than sequential activation of neural pathways. The speed here would be the speed of correlation collapse, which is instantaneous regardless of spatial separation, although, again, this instantaneous correlation cannot transmit new information faster than c in a manner accessible to classical observation. However, the internal speed of cognitive synthesis might leverage these correlations to achieve integration rates that dwarf the capabilities of light speed-dependent classical computation. The contrast deepens when we look at the future of technology interacting with the mind. Current breakthroughs in brain-computer interfaces, such as those being developed by Neuralink or similar ventures, aim to increase the bandwidth between the brain and external digital information repositories. These interfaces, relying on electrical signals transmitted through physical media or wireless links limited by the speed of light, are inherently bound by c. If a human mind could somehow access the totality of the internet, the entirety of recorded human knowledge, the speed at which they could assimilate this data would be limited by the time it takes for the light signals carrying the data to enter the brain's vicinity and be transduced into neural activity. Conversely, if the awakening implies a radical shift in the nature of awareness, a state where the perceived separation between observer and observed dissolves, perhaps approaching states described in deep meditative traditions or psychedelic experiences, then the concept of speed might become utterly meaningless. In such states, time itself, which is inextricably linked to the spatial dimension via the light-speed constant in Minkowski spacetime, may cease to be a relevant metric. If the entirety of an experimental timeline is collapsed into a single, eternal moment of pure apprehension, what is the velocity? It is zero relative to a temporal axis that no longer exists for the observer, or infinitely fast, having traversed all possible temporal states simultaneously. This mirrors the concept of the Planck epoch in cosmology, a moment where the four fundamental forces were unified, and time and space as we know them arguably did not yet apply. Let us consider a concrete analogy to highlight the difference between physical speed and informational speed in this context. Imagine two runners. Runner A sprints across a desert at 99% of the speed of light, the maximum physical velocity allowed. Runner B sits still at the starting line, but possesses a complete, universal library of all possible maps, all logistical knowledge, and an instantaneous deductive engine. When presented with a novel, complex maze, runner A will take a measurable, albeit short, time determined by the maze's physical size divided by their near-light speed. Runner B, however, might instantly visualize the optimal path, having processed the entire state space of the maze in one cognitive leap. While runner A moves physically faster, runner B processes information functionally faster relative to the task of navigation. The awakening suggests that the human mind, through deep integration or higher-order processing, might become runner B writ large, capable of instantaneous state-space collapse. The challenge in definitively claiming consciousness is faster than light lies in defining the metric of its speed rigorously enough to compare it to the rigid definition of c. Light speed is the maximum speed of causal influence propagation through spacetime. If consciousness operates upon or outside the structure of spacetime, or leverages aspects of reality currently inaccessible to classical measurement, then the comparison shifts from apples to oranges, a comparison between a physical constant and a subjective potentiality. The ongoing search for gravitational waves, detected by LIGO and Virgo, provides another fascinating anchor to the speed of light. Gravitational waves, ripples in the fabric of spacetime caused by catastrophic cosmic events like the merger of black holes, also propagate at c. The detection of GW170817, the binary neutron star merger, allowed scientists to confirm the speed of gravity is equal to the speed of light with unprecedented accuracy, binding the mechanics of spacetime itself to this universal constant. Any cognitive mechanism claiming supremacy over c would need to imply a means of influence that does not propagate through, or is not constrained by, the metric tensor of spacetime that dictates the speed of both light and gravity. What if the awakening is fundamentally linked to the manipulation of quantum fields in a way that allows information to decohere in a preferred, instantaneous manner across vast distances, bypassing the light cone? This leans heavily into interpretations of quantum mechanics where consciousness plays an active role in wave function collapse, an idea famously, and controversially, associated with figures like Eugene Wiener. If the act of conscious observation fundamentally collapses the probabilities defined by the Schrödinger equation, a process that, mathematically, appears instantaneous across the entire superposition, then the speed of that collapse, the realization of a definite state, would indeed be superior to c in terms of information transmission across the spatial separation of the entangled particles involved. While standard Copenhagen interpretation maintains that no information is transmitted faster than light via this mechanism, a highly conscious, awakened entity might perceive or interact with the totality of the collapsed state simultaneously, effectively achieving instantaneous knowledge transfer across the system. The concept of awakening also finds parallels in theoretical computation complexity. If classical computation is linear or polynomial, limited by the sequential nature of operations, and thus, by the speed of light governing the speed of the transistors, then a sufficiently advanced consciousness might operate via principles akin to quantum computing, where massive parallelism allows for factorization or searching across an exponentially large search space in polynomial time, a significant functional speedup compared to classical methods. The speedup here is algorithmic, a revolution in how the computation is organized, rather than the physical speed of the medium carrying the computation. If human awakening represents the transition from classical cognitive processing to a quantum cognition architecture, then its effective velocity of knowledge acquisition would appear instantaneous relative to light-speed-bounded thought processes. Let us explore the implications of this algorithmic speedup in practical terms. Suppose an awakened mind can model the future trajectory of a complex chaotic system, such as global weather patterns or market dynamics, not through iterative simulation bound by the speed of light processing cycles, but through a direct mapping onto the system's underlying informational structure. The time difference between formulating the necessary equations, limited by c, and perceiving the outcome, limited by the processing architecture, would be minimized to the point where the functional speed of insight vastly outstrips the speed of any signal traveling at c within that system. Furthermore, consider the subjective experience of time dilation in relation to velocity. Special relativity dictates that as an observer approaches c, time slows down for them relative to a stationary observer. If a consciousness could somehow achieve an arbitrarily high velocity, even if it remained strictly below c, say 99.9999% of c, their subjective experience of external time would slow dramatically. For the traveler moving near c, a journey across the Milky Way might feel like a few years, while eons pass on Earth. In this scenario, the speed of light creates a perceived superspeed for the traveler's internal clock relative to the external universe, although the traveler is still bound by c. However, if the awakening allows for a decoupling from the relativistic effects of mass and velocity, perhaps through a non-mass-bound informational state, then the subjective experience of time dilation becomes irrelevant, and the speed of understanding transcends the universal speed limit by operating outside the constraints that cause time dilation in the first place. The debate hinges on whether consciousness is purely an emergent phenomenon of classical physics, in which case it is fundamentally bound by c, albeit a very complex manifestation, or if it taps into deeper, non-local, or quantum aspects of reality that operate independently of the spacetime metric defined by c. Recent studies in cosmology, particularly regarding the late-time acceleration of the universe driven by dark energy, suggest that the expansion of space itself can exceed the speed of light between distant points. This is not a violation of special relativity because the objects themselves are not moving through local spacetime faster than c, rather, the fabric of spacetime between them is expanding. If consciousness could somehow align itself not with the motion through spacetime, but with the expansion of spacetime itself, a sort of cosmic resonance, it might achieve a form of information transfer or perception that moves at the speed of cosmological expansion, which, at vast scales, effectively exceeds c. This is a highly metaphorical connection, certainly, but it illustrates that the universe contains velocities greater than c when considering the dynamics of space itself. The awakening could be interpreted as achieving perfect alignment with the universe's underlying informational substrate, perhaps perceiving the universe not as a collection of separately moving objects constrained by c, but as a single, unfolding metric governed by the expansion rate. In conclusion, the speed of light, c, remains the undisputed champion of causal velocity within the material reality described by our current best theories of physics, the speed limit for energy, mass, and classical information transfer. It defines the horizon of our observable universe and the structure of causality. However, the concept of the awakening of human consciousness introduces a competing, qualitative velocity, the speed of insight, integration, and subjective apprehension. If this awakening involves the utilization of quantum non-locality, massive algorithmic state-space collapse, or a fundamental shift in the observer's relationship to time itself, then the effective velocity of information processing and comprehension achieved by the awakened mind may functionally, if not physically, exceed the constraints imposed by the speed of light. While light dictates the maximum speed of a photon crossing a room, the awakened mind might instantaneously traverse the conceptual distance between two profound, seemingly unrelated ideas, a journey whose cognitive speed challenges the tyranny of the cosmic constant. The pursuit, therefore, continues, a race between the immutable laws governing matter and energy, and the seemingly boundless potentiality residing within the structure of awareness itself. The final answer likely rests at the intersection where physics meets perception, where the rigid structure of spacetime yields, however temporarily, to the emergent power of integrated understanding. The material world is constrained by c, the world of meaning, perhaps, is not.